All right, with great data comes even greater access latency. Welcome to the Trino Community Broadcast, where we transform your latency woes into fast insights. The Trino Community Broadcast is a show where we cover events and happenings within the open source Trino community and show off some cool stuff about Trino. I am your host, Brian Olson, co-host.
And I'm that other co-host, Manfred Moser, and we have two awesome guests today as well from the Apache Superset community. Srini and Beto, welcome.
Welcome.
Hey, thank you.
Hey, great to be here.
Yeah, we're gonna make you hang out with us today. So
yeah, sorry about that. So basically, this week we have a lot of cool stuff. We unfortunately this week did not get to a release that we can talk about all the way yet. But I would like to, whenever you do talk about the release, Manfred, maybe I don't know, do you want to hint at anything, or do we want to just save it for the next show? Because there's a really cool feature coming out.
Remember, this is an open source project. Everything is out there.
That's right.
You can just see it.
That's also true.
We are assembling the release notes for 353. It's like literally around the corner. With a little bit of luck, on Monday you'll have the binaries ready for you. So
yeah. So this episode we're so we got these wonderful folks from Preset, which is a company that builds on top of Apache Superset. It's an open source visualization platform, and I'll let them talk a little bit more about what it is here in a little bit. But we wanted to kind of show, we have kind of members from both communities here joining us today. We wanted to kind of touch a little bit on what is Trino and kind of what we do. And we're also going to go into, from a Trino perspective, talk a little bit about clients in general. And that's going to kind of motivate us and move us towards maybe talking about the Apache Superset, getting into more of the interview. And then basically... We'll do a couple fun little demos, and after that, and this demo is going to be some pretty cool data set. It's some mixing, of course, the data set that everybody sees nowadays, COVID, plus plane flights that are going on. So it's kind of cool to see some of the correlations and things that are going on between the two data sets. So it's probably a lot of things that you'll expect, but it's cool to verify our expectations in data all the time, anyways. So why don't we just go ahead and Manfred, do you want to just talk about the little bits and pieces about 353, and I might chime in with my one little feature that I'm super pumped about.
Well, so for 353, we wanted to cut it really quickly after 352 because there was one sort of correctness bug, but time ran away with us, and a whole bunch of more documentation and other things are sneaking in now. So it's going to be a sizable release again, not like the usual a whole backload of stuff, but it's going to be sizable and have a few good improvements around like the Kafka connector and stuff like that. So
can I tell you my one feature that I just found? I literally found out about this last night. I think we just got added to the release very recently, and that is
the ClickHouse connector.
Ah, damn you! so ClickHouse connector is getting added, and yeah, it's been in the making for like the last 8 months now, I think, and it was contributed by. I think somebody who's pretty new to the Presto. Oh my God, there I go again. Trino community, and yeah, they basically added this on. What's cool about this is like this falls into a kind of a category of databases that really narrow in on the sub-second latency stuff for like kind of doing stuff that we're empowering today, like Apache Superset, Pinot, and databases like Pinot, ClickHouse, and Druid. These are like kind of the three players in the space that handle a lot of this. Like they do these custom indexes, they handle all this real-time stuff just so that like you can get your data as quickly as possible, and then like search it and like very quickly update like your graphs or any of your visualizations on the front end. So that's where these things kind of specialize. And so we had two of them. We had Druid and Pinot, but now we're adding in kind of the third big player, and I think that's huge for us to get all three, because I know ClickHouse ClickHouse is just, I mean, I'm seeing it everywhere. It's growing in popularity. I didn't see it for the longest time, and then I read this blog, and it's like I saw it everywhere. It's like when you buy a car of a certain like make and model and color, and then you see that car everywhere once you say that's practically what I felt like when I learned about ClickHouse. So very excited about that feature. We'll talk about it a little more next show whenever we get more in the nitty gritty of 353, and who knows, maybe 354 by that time. So with that, Manfred, do you want to take it away on concept of the week?
Yeah, that's actually a good kind of like a segment, because you're talking about a ClickHouse connector, and that's an important concept. So to understand, as an Apache Superset user maybe, and what Trino is a distributed massively parallel SQL query engine. So that's a mouthful, but what does it actually mean? So Trino was founded as Presto at Facebook in 2012, has been around for a really long time, and it was created to query Hive data, so a Hadoop file system with the metadata in Hive at high performance. So it's much faster than HiveQL, and it uses normal standard SQL. What then, however, happened is a plugin system was introduced where you can create connectors. And what Trino allows you to do now is you can use the same SQL query language implemented in Trino / formerly Presto against any of the connected data sources. So you can connect, I don't know, Azure storage or a Minnow file system or a Kafka stream or Elasticsearch engine index, and of course also things like ClickHouse or relational databases like Oracle or Postgres or whatever. All of those can be connected. All of them are available for you to query at the same time via the standard SQL. And of course, that's great to query multiple data sources and have collections between them, right? Like maybe you have a web traffic log that's pumped into Elasticsearch, but at the same time you have an Oracle customer database that has the records for that, and you want to sort of pull that data together. Trino allows you to do that with normal SQL queries, and that's where clients come into place, right? Like Trino is very fast. It runs on a cluster with multiple nodes. It's optimized for analytics, and it allows you to query it with SQL. But obviously that's kind of awesome, but who wants to really write all the SQL queries, right? Nobody does, right? And that's where clients come in order to connect like some sort of more powerful tool, especially awesome visualization tools like Apache Superset. You need some sort of client connection so that it can talk to Trino, so that Trino can then on its behalf talk to the underlying data sources. And that's what we want to talk about today. So in the past, in past episodes, we talked about how Trino receives the query from the user or the tool, and then goes through query planning, optimizes how to read from multiple data sources, how to parallelize the reading, optimize the query plan, all sorts of like low-level details. Now, what happens on the other end is what we talk about today. So once you have a connected data source, and Trino knows about the query it needs to run, the individual Trino workers in a cluster, you can have anywhere from 2 or 3 of what we call workers to literally hundreds or more, and they can all talk to the data sources via the specified connector. So if you want to talk to a PostgreSQL database, you have the Postgres connector configured in your catalog. So those workers talk to the data sources, get the data, then they talk to each other and do aggregations and all that kind of stuff within Trino. And then they get it all back to what's the final sort of the orchestrating node in a Trino cluster, which we call the coordinator. It does the final processing. So it then aggregates all the information. It is also the one where it all started, like it received the query from the user and sent out, like created the plan and so on. But in the end, ultimately, the data comes back to the coordinator, and the coordinator supplies it back to whoever requested it via HTTP. So there's a HTTP/REST kind of interface that is provided to the clients. And that client can be default clients that we have, such as the JDBC driver or the Trino CLI. They kind of wrap that HTTP traffic, and they translate the data then further into whatever user interface there is. Like if you write a Java application, then obviously you don't want to have to talk to the REST API. You just use the JDBC driver.
And Manfred, like so basically, when you say wrap, it's basically making those HTTP REST calls for you. It's already
exactly
it takes
right?
those inputs.
Yeah, when you have a Java application, you just go connect via like you open a JDBC driver sort of thing connection, and then you can go like give me the record set, and then the client, the JDBC driver knows how to do that. Yeah. The CLI, the Trino CLI makes even more. You can type your SQL query, and it does all the thing all the way in.
Yep.
And then of course, as a user, then you see the data, right? Like say you run a query and you return like a couple of thousand records. Well, you'll see the first 100 on your screen, and then you got that streamed back. The client, and then once you like press like next page or whatever, the client potentially goes back and gets more of those that data, right? So it's not a pure REST API sort of thing because it has to stream the data, obviously, right? Like there can be tons and tons of data returned, especially with like rich visualizations and stuff like that in Superset. That goes a lot more. So you should be using what we call a Trino client if you want to interface with Trino, or an application that uses a Trino client. So what Trino clients are there? Well, from the Trino project, we have the JDBC driver, obviously, very popular. Automatically opens up all the applications that are written in any sort of Java-based framework, or also Scala, like the quick visualization tool and others. We have the Trino CLI, which is a command line tool that runs on Linux or whatever. It's Java written command line tool, which allows you to run it anywhere and write the queries yourself. But it also has like a pager built in and all sorts of stuff like that. So it's also pretty handy even for just testing. We then importantly have a Python client, so the Trino Python client. We have a Trino Go client. All of those are maintained by the Trino project, and they get like features added, like, you know, support for different authentication systems and like all that kind of stuff. And then in the community, there's more things. So there's, for example, mine and Brian's employer, the sponsor of this podcast, which supplies a Starburst Enterprise, which is a sort of commercial distribution of Trino, also offers a ODBC driver. So if you have some sort of Windows application that needs ODBC rather than JDBC, then you can connect that on Windows or Unix or whatever. And then in the community, there's also clients for like tools like R or Node.js and other libraries like that.
Yeah.
Now, the Python world, that leads us a little bit towards Apache Superset, because Apache Superset is written in Python pretty much, as far as I know. Not all the way, or is it all the way?
Nice.
Well, the front end is JavaScript, React.
Yeah. Well, yeah.
The back end is Python. We're working on a Node.js sidecar also for async queries.
Oh, okay, cool. So it's in Python, and as you can see, I'm not a Pythonist or Pythoneer at all.
Python noob.
A Python noob, yeah. Like, obviously, I've written in many programming languages, but I never dove deeper into Python. But I know enough to be dangerous. Let's just say it that way. So what happens in Python is there is a typical API to interact with databases. It's called the DB API. Version 2 from PEP 249 is now sort of like the standard, and it's basically part of the standard libraries that every Python program uses. The Trino Python client that we maintain basically provides an implementation of that API. So it handles the whole complexity of the REST API for you and exposes a standard DB API for Python users. So that's pretty awesome. And it supports like authentication and like the usual DB API endpoints. That's essentially the preferred endpoint, the preferred way to connect to Trino if you are writing in Python, because otherwise you have to implement the REST API, and that's a pain. So, so the DB API is really good, but it goes a bit further. So in the Python world, there's a bunch of other things that are suitable or sort of like are used as well. So there's SQL Alchemy. That's a SQL toolkit. Actually, is it called SQL Alchemy or SQL Alchemy? I don't know.
That's a good question. I say SQL Alchemy. I think most people say SQL Alchemy.
We're gonna lose a lot of
I
fans.
think it's SQL Alchemy.
Yeah, I was on a podcast a while ago, and we were talking about Presto and Presto SQL, and I just said SQL, and later I got the feedback, you shouldn't have said SQL. SQL is SQL. Everything else it's so wrong. And I'm like, yeah, whatever, you know. Give tomato. That's the kind of thing.
Yeah, I think when SQL is like standalone, people say SQL or SQL, but then when it's merged onto another word, they always say SQL. It's a funny thing.
Yeah. But basically, so SQL Alchemy is an SQL toolkit, so it provides a whole bunch of features on top of the DBA to make it more useful. It also is an ORM mapper, but that's kind of like a separate tool. It's not really necessary. And that's very widely used, including Apache Superset. And I think it is also the tool that supports multiple dialects. So as you know, SQL is awesome. It's standardized, but it's also terrible because no one really follows the standard. So like, Trino is actually super awesome because it follows the standard very, very closely. So if there's one database that tries to follow the standards very closely, it's probably PostgreSQL. Trino is in that level, like it follows the standard very, very closely. Martin, Dane, and David are like deep SQL nerds, like looking at the standard and stuff like that. And whenever there's a decision to be made about what is implemented, they always like follow the standard. And it's proven to be really, really awesome because tools like Superset can rely on it and don't have to like, you know, code around the weird words of like that specific SQL alchemy. So SQL Alchemy is that sort of like has an implementation layer around that. And I think then Superset uses that. There's a couple of other things in Python that I want to mention, and maybe Srini and Beto, you can explain to me how useful they are. So there's PyHive, but I think that's kind of silly because PyHive basically is there to run Hive queries. So if you run PyHive with Trino, that's kind of pointless because then you run HiveQL into Trino, which actually expects SQL, so it's only going to kind of work.
Right? Oh no! So well, you send the SQL yourself. So PyHive started as a Python DB API library to Hive and Presto, and it handles the connection, but you still need to send the SQL.
But okay. So when you write it, you can write normal SQL and PyHive passes it.
Yeah, so if you're connecting to Hive, you would send like Hive SQL, HiveQL, and if you're sending to Presto, you would send ANSI SQL or Presto SQL. Or
so what's the point of using that with Trino then?
It implements the REST API, right?
Yeah, but I don't know. Like, you might just use the Trino Python client then. Like,
yeah, but the Trino Python client is new, right?
Yeah, well, yeah, I guess it used to be called the Presto Python client. It was always there as well. So I think maybe it's just historically that the two of them around. I was
because PyHive is by Dropbox. I actually didn't know that Presto had a Python DB API before I heard of the Trino client.
Okay, yeah, no, that's been around a long while. It's been called the Presto Python client. But anyway, so that's around. And then the other two that I found exist as well is there is the you can use the JDBC driver with PySpark, and I think that's actually using PyJDBC, which is another library. That seems a bit crazy in my opinion, because then you run Python natively, then you fire up a Java virtual machine to use the JDBC driver to go to the REST API go to that. Doesn't make sense, right? Like I guess it's kind of workable, but it seems like a silly idea.
Yeah, that sounds crazy.
Yeah, and then there's also ODBC, same idea, right? So
which we use for some of our adapters.
Yeah, so that's sort of how the clients hang together in the Python world. And one of the most awesome tools out of the Python world, in my opinion, is Apache Superset. So tell us, Beto and Srini, what does Superset do, and how does it hang in with these clients?
Srini, do you want to start?
Sure, I'll go first. So Superset, the quick story is Max was at Airbnb trying to visualize Druid data, and I think he kind of noticed all of the rest of the modern data stack has been open source, and there's a lot of value there. Obviously, Presto and Trino, right? and but the BI layer was still very much kind of you were stuck by whatever the vendors wanted to do. There were a few open source BI options, but none that were that mature. Um, and so Superset kind of came out of that desire of like, I want to be able to visualize data and create charts and dashboards from wherever my data lives, right? Similar to Trino and Presto, right? Like, why should you be limited by where your data happens to currently reside? And so that's kind of originally the vision, the kind of burning desire. And then since then, it's obviously grown to become a much larger project. But yeah, and I think one of the nice things that Max and the community, the rest of the committers have really bet wisely on is betting on these strong open source components. So the DB API, SQL Alchemy, and then even on charting now, the project is moving to eCharts. So there's kind of this long history of picking nice open source partners and components so that Superset can really work with any SQL speaking database. It's not perfect, right? Like as we just discussed, to talk to some databases, there's some hacky things that have to be done, but it's kind of built on a good foundation. And then Beta can go a little bit deeper. Yeah.
There's a fun story. Like, so Superset started as a UI to Druid because like BI tools, they didn't talk to Druid because Druid was new. So Max wrote Superset as a way to talk to Druid. Druid didn't have a SQL interface back then. You would send like a query represented as JSON. So basically like, hey, these are my group I's, these are my metrics, and you send JSON down the line. So it started as, it didn't have SQL at all. It started as a UI to Druid. Eventually, they realized, oh, maybe we should use this to talk to SQL databases. And they implemented, using SQL Alchemy, they implemented a path to talk to SQL databases. So for a long time, we still have this. We have two paths for running code. One is called the native Druid connector, which sends JSON. The other talks to any databases that SQL Alchemy supports. And then you send SQL down the line. And then eventually Druid got a SQL interface, a SQL API. So we implemented, I created the DB API interface for Druid, the SQL Alchemy dialect. So now we can talk to Druid in two ways, and we're deprecating the old way. So of course, SQL is much more flexible if you want to define custom metrics, if you want to like express these transformations. So we're just like phasing out the idea of a native connector that requires custom logic, custom way of representing metrics, and just like sticking to SQL. Yeah. So and like Srini said, I think like the beauty of Superset is like coming from an open source development model. Things are modular, so it's easy to add new connect. So it's really easy to iterate, right? If we have like a user or a customer preset who wants a new database connection, we can quickly implement that. If they want a new kind of visualization, because it needs to be used by multiple companies, we can't really force decisions onto the product. So everything has to be agreed. We have a process to decide what goes on Superset. So visualizations, they're modular. You can install some visualizations. Some people, they don't want to have those visualizations. So we end up coming with we came up with the modular design. So adding new visualizations is also easy. They're just like plugins that you can add. So that makes the product very flexible. There's a lot of abstractions and interfaces that make it easy to adapt to your system. If you want to connect to custom authentication, it's relatively straightforward. If you want to add like custom event loggers that send the data to some custom database, it's also easy, because we have this need of supporting different infrastructures, and like the product grew out of multiple companies.
That's cool, but it's from all I understand, it's Apache Superset, right? So it's an Apache Software Foundation project. I guess all the components then basically are Apache licensed or at least compatible with it, right?
Exactly, yeah.
So are you on the PMC?
Yeah.
Like, are you like? So, sorry, I have to like clarify a few terms. Before we kept talking about BI. For those that don't know what BI means, it stands for business intelligence. It basically means the whole reporting and getting data out of systems. And PMC is the project management chair. So in the Apache Software Foundation, an open source project has to be managed by a committee of sort of like actual committers and then like sort of leaderships for the decision. So are you on the PMC for?
Yeah, I'm on the PMC, and like I mentioned a little bit. So Max wanted to open source Superset. So he was able to get Airbnb to give the IP to the Apache Software Foundation to make a like truly open source project. And being in the Apache Software Foundation, there's like procedures we follow. So you can only commit if you're a committer, and to become a committer, there's a process where your work. So you start working with Apache Superset, and then eventually you get voted in as a committer, and then after a while being a committer, you can be voted in as a PMC member. And we also have a process called the Superset Improvement Proposal. So this is similar to other projects.
It's very Python-y.
Yeah. So if you wanna and
Zip
this
and PEP, right?
yeah, well, we call it SIP because it's Superset Improvement Proposal.
I know, and it's a PEP to Python.
Yeah, similar to Python.
Yeah.
Kafka has KIP. And basically, like, this also arose from like having a product that was basically built cross companies, where if I want to introduce something that's like radical, we need to have an agreement. So there's a process where if you're introducing breaking changes or like any radical changes, you need to write a proposal. You need to describe what are like the side effects of your proposal, any dependencies you're adding, and any alternatives that you considered. So not just like, hey, this is what I'm proposing, but I also looked into these other things. And then it gets discussed on the mailing list, and then we have a week to vote. And it's very conservative. Like if you get one veto, that's enough to like block it. We never had any vetoes though. Like it's a very friendly, united community.
I was just gonna say, you're scaring people away here. Like it's not that hard. Like I mean, yes, that's very like it's an awesome process and stuff. And I'm an Apache committer myself, so I know like this works really, really well. But on the other hand, don't be scared. If you want to help out Apache Superset or any other Apache project, you can just send pull requests or other contributions, and that's totally fine as well.
Thank
So you're telling us it's not like Congress, okay?
And we have like we have tickets. Like if you want to get started, we have tickets that are marked as like starter tasks. Like I said, you can't actually commit to the repo, but you can create the PRs, and then a committer will merge it for you.
That's
it's a
the
super
same in
friendly
Trino
community.
as well, by the way. We're not an Apache project. We have our own Trino Software Foundation, but it's very similar. And maybe we should start having a tip. Trino.
There you go. Tip.
Yeah.
Nice. So
now, how long has Superset been in the Apache community and around? Right, it sounds like it's quite a history, right? Like, I mean, also in considering how powerful it is, it must have been around for a while. Like, if you see later in the demo, it's pretty amazing.
Yeah.
So I think it started 2015 or.
Yeah, it was called Carvel. Carvel at the time?
Well, it was started as Panoramics.
Oh, that's right.
I don't know if you're familiar with Panoramics. It's a druid from the comic book Asterix.
No.
Okay.
It's
Very
not
cool.
super famous in the US. I think it's more popular outside of the US. But like Panoramics was a druid, so since Superset was a UI to druid, it was called Panoramics, and then Airbnb said, well, this is like a copyright violation. It was renamed to Caravel. I remember seeing like some reference to Caravel in the source code still. And Caravel was also deemed like politically incorrect because of the implications of Caravels coming to America.
Yeah.
And
naming is hard, man. Like when we had to rename away from Presto SQL, finding a name, it's not easy. And any programmer knows that anyway, right? Like just like, I don't know, like sometimes in pull requests when people start arguing about variable names, it's just like, okay.
Yeah. Well, it's one of the hard problems.
Yeah.
I'm searching for, how do you spell panoramics?
Panorarix.
I used to read I'm from Europe myself, so I used to read those comics as a kid, but I read them in German, and that druid used to be called Miraculix back then, like miracle.
So just 2 weeks ago, I went.
Yeah, and then from Caravel it became Superset.
Do you know when Superset joined the Apache? So maybe you want to talk about the incubation process a little bit.
It was early on, I think. So I started working in Superset. So I have a long experience with Presto/Trino. I worked at Facebook, so I've been using Presto/Trino for I don't know, since 7 years ago. I'm a big fan, so I'm happy to be here.
Well, what was it like working on the outside of the at that time Presto team? You know, going to Martin and Dane and David. Was it like the back end guys, or were they pretty open?
So we had a project. So we were the first customers of the Raptor connector, which was, I think, called the native connector. Also, we needed like, we were doing building a tool to analyze experiments in real time. So we needed to analyze a lot of data in like sub-second latency. And it was a really hard project. I think for 6 months, our team actually moved next to the Presto team at Facebook, so we could like work together and make sure we would make the deadline. It was a bit stressful, a lot of late meetings, but we made it. It was really amazing. Like all the improvements in performance, like the team got. And then I left Facebook, joined Lyft in 2017 to work with Max on Superset. So I joined Lyft to work on Superset. Back then, it was already in the Apache Software Foundation as an incubator project. So once you join the Apache Foundation, you're in the incubator stage where you're just getting your project ready to mature, which for us took a long time. I think sometimes I think Superset might have been open source a bit too early. So I think during that time from 2017, 2018, there was a lot of refactoring, a lot of decisions that were like referred to, like not referred, but like we still had jQuery code in Superset back then. And so there was a lot of refactoring, and because we had already, it was open source and multiple companies were using, it was hard to do like these hard refactors. We were like, well, this is what we're going to do, right? You need to like always implement like a V2 parallel to the V1, and then eventually deprecate V1, and then eventually switch to V2, and then delete V1. So everything was slower. And we graduated last year. So it took us, maybe 3 years, not that long, I think.
But that's a great achievement. Like, I mean, I was involved with one project going into the Eclipse Foundation as well. And there's just a lot of things that, like, when you just like make a big open source project and you just throw it across the GitHub and make it public and say it's open source, that's a total different ballgame to having like a well matured, well managed project with like the right licenses or the libraries and stuff. It's a different beast, and like it's work, and like, congratulations, it's good, like you did it.
Yeah,
thank you.
And also reaching top level, right? So cool. You were once you said we were finishing off at the story with Lyft, right? And then what I do want to kind of close the gap on. Went to Preset, right?
Yeah, so I joined Lyft to work on Superset, and Max left after a year, started Preset. And I still wanted to like stay at Lyft and develop Superset. And like that time I did a lot of work. We were using Presto SQL, Trino. And so I did a lot of work. It was our main database. So I did a lot of work to get Superset having like nice features with Trino, like the complex column types. So we can like expand like objects into pseudo columns, and like arrays into rows. We did a lot of work with like query cost estimation. Like that was a big thing at Lyft, saving money, trying to become profitable. So we did a lot of work into estimating queries before you ran them. And then eventually, like I started working on other things, and I realized I didn't want to work on other things. I wanted to keep working on Superset. So I joined Preset. That was last year, September.
Nice.
Awesome.
Yeah.
So could you explain a little bit, like you enter a query in and you submit it to, let's say on the SQL lab, or maybe like a virtual data set, and we'll get into more, like I think it'll be easier to see these kind of visually when we go through the demo, but there's kind of these, ways that you'll submit a query. Could you kind of explain the flow now that we've kind of got a very good idea, a mental model of like what clients are sitting underneath Superset and how that ends up getting at least submitted to Trino, but you can kind of envision the same with other databases. So what's the journey of a query, I guess, in Superset?
Yeah. Let me just like step back and go first, like bottom up, and then I'll go from the query. So Manfred mentioned we have in Python world, we have the Python DB API, which was a huge step forward because before people would implement clients to talk to databases, and each one would have its own API. So there was the first version, we were in the second version, and it standardizes the APIs in like the objects, the connection object, the cursor object, which methods you have. It's not a perfect abstraction. There's some libraries, they implement some things slightly different. The way you pass parameters to the query, right? So when you're like writing Python, talking to a database, you don't want to add the parameters to the query as like using string interpolation, because you're opening to your SQL injection attack. So you basically put placeholders in your SQL query, and then you pass the parameters separately and let the database replace the placeholders with the data. Different DB API libraries, they do that differently. So SQL Alchemy is important for us because it offers that abstraction layer, right? And with SQL Alchemy, you can write. One thing I discovered the other day, I was working on Firebird. Firebird doesn't support the limit expression. You actually do select first 10 instead of select and then limit 10. So SQL Alchemy takes care of that. If you write a SQL Alchemy query and you say, hey, I want to limit 10, it knows, okay, I'm going to use the Firebird dialect, so I'm actually going to write select first 10. If I'm talking to Trino, I'm going to do select star limits 10. So SQL Alchemy offers that abstraction layer, but that's still not enough for us. We have our own abstraction layer, which is called the DB Engine spec. And it basically started as a way of having a consistent way of computing time granularities for time series, right? So if I have some data and I want to have it like hourly values. In some databases like Postgres, I can do date trunc hour, and it truncates to hour. Other databases are more complicated. So all of those definitions, they live inside Superset. It's called in the DB Engine spec. So I think the first thing was just getting the time granularity right, so we can do like, and there's like some complex ones, like you want to look at week starting Sunday, or you want to look at just weekly data. And then there's a few other things, like some databases, they don't support joins. Some databases don't support like subselects. So all the things we need to know, because we build queries we build queries automatically for the user, depending on where you are in Superset. The thing about Superset is I like it because it basically democratizes access to data. If you want to write SQL, you can go and write SQL. If you want to just explore a table using a web interface, you can just click and visualize data. And if you don't even know how to do that, somebody can do an interactive dashboard that you can at least like add some filters or click on the drop downs and see how the data changes. So it caters to a big audience. So basically, like if you're in SQL Lab is our SQL ID, the SQL that the database you're talking to expects, right? So it's basically like a low-level interface where you write SQL, we send it to the database almost unmodified. The modification we do, you can define. So the configuration for Superset is defined in Python. There's a Python file, which is great because it's very flexible, but it's also very dangerous, right? Because you have basically Python code as configuration, but you can define a function that mutates your query before sending it. So the function gets the query, gets some context, and you can modify the query. At Lyft, we use that with Trino to annotate the user that ran the query. So we would add a comment with like a little JSON payload in the beginning of the query, and it would basically say, oh, the user that ran the query is this person, and these are the tables that they're querying, and this is the timestamp or things like this. So in SQL Lab basically goes through that mutator, and then you run, and you can have sync or async queries. So if you have an async query, basically you submit to a queue, and then the worker is going to pick up that query. It's going to submit the query, and when it's done, it will put the results in the results backend, and then SQL Lab will fetch the results from the results backend. And if it's synchronous, then you basically wait for the data to come back.
So you mentioned a user. So just from a practical point of view, typically in an organization like Lyft or whatever, you would have your Trino cluster, you would have your multiple databases, and then you run a server or a cluster of servers for Superset, or how does Superset scale in that kind? Like, oh, how heavy is it even? Or do you like how many concurrent users do you typically have on one server, or how does that work?
Yeah,
Because
I
it's
think
multiple user interface, right? Like you
yeah,
log in.
yeah, you log in, yeah. It's pretty lightweight. Like Superset is basically doing the glue between the user, and then even if you write SQL directly or indirectly using the Explorer view, right? The Explorer view, you just click and we generate the SQL for you. But it's basically the glue between sending SQL to, like, routing SQL to databases, getting the results back and showing to the user. And then we have JavaScript libraries to visualize. So it's pretty lightweight. You can like scale it horizontally trivially because it's just like web servers, basically, like I said, routing requests from users to databases and sending the data back.
So it's a lot of Java client-side JavaScript and a couple of Python implemented web APIs that talk to it, and then that just goes over to the database.
Yeah.
Oh, cool.
Yeah.
Very nice.
And at Lyft, we realized there's a lot of value also just in the Superset backend. We had teams working, building custom data visualization. Like one of, I think, the biggest advantage of Superset, it's very generic. You can do a lot of stuff. It's self-serve. But if you want to build custom data visualization applications, like at Lyft, we wanted to have like ride replay, so you can like look at what happened during a ride. Building that with Superset would be hard. So people started building custom data applications, data visualization applications, and we basically told them like, hey, Superset has an API. We already implemented access control. We have caching. We already talked to all the databases. Like, write your application and talk to the Superset API to get your data. So that's another like big use, was like a lot of people.
So
are
it's
just
like
using
an
the
alternative web interface for the same REST API, basically, in a way.
Yeah.
That's cool.
So it's something you just mentioned there too, the caching. Can you go into a little bit of like how Superset handles caching, what it's caching, what it's not caching, and that kind of?
Yeah, we use, again, going back to the open source, we use an abstraction. So there's a Python library called Workzoig, and they implement a caching API that can be in memory, can be file-based, can be like memcache, Redis. So basically in your configuration file, you import a class that implements the caching API and you point to that. So it's very, very flexible. And we usually cache. So the cache, I mean, we talked about naming things. Caching is the other hard problem.
Definitely.
But you can specify like per database timeouts for cache. We try to cache as much as possible while being like aware that some users have access to something, some users don't. So you can't really reuse the cache blindly, right? It has to depend on the context. But when you run and like caching is hard, because if you run a query in, like, if you run a Trino query and you have like select star from table where I don't know, date is greater than now minus 7 days, right? If you cache that like blindly and you run the query, if you run the same query a week from now, you should get different results because now changes, right? So I know Airbnb worked on taking care of these edge cases where if you have functions that are non-deterministic, you shouldn't cache the results. I also worked on an experimental browser cache. So like some things we can cache on the browser, and we basically use e-tags. So when you get a response, when the browser gets a response from Superset, we send the hash of the resource. And later, if the browser, so this is especially for making dashboards fast. So if you load the dashboard for the first time, every chart that you get a hash of the content. And then later when you load the dashboard, your browser will automatically send that hash, and Superset will see if the content is the same. You just say, hey, the content has not been modified. And then the browser doesn't need to download anything. It's just like a quick request without a payload. Yeah, but that's also experimental. Like there are a few edge cases. There are many edge cases, and like for that work on the browser cache, there were a few edge cases that were not, I think, captured correctly. So it's too experimental, and we need to do some work there.
Well,
Very interesting, though.
and those are edge cases. Like the general usage of Superset is already pretty amazing. So I'm not sure, but do you think we want to just like dive in and have a look, Brian?
Yeah, I'm down to. Unless do you guys have any? I mean, sorry, we kind of just interrogated Beto the whole time, and we didn't ask Srini anything. But
I just want to make a comment. Like, as an engineer, I always see the bad sides of Superset. Like Manfred said, the project is amazing. It's like, I love you. I use it every day because I really try to dog food. It's an amazing product.
Yeah.
But as an engineer, we're always like fighting with the bugs.
Yeah.
So
Yeah.
that's what's on my radar.
And it's funny though, because it's just like, that's, I think when we're on a talk show like this, like a good amount of the people listening in are engineers, and they like to know, they understand that there are problems with any system, there are bugs, and if you are saying there are not, they're not going to eat any of that. So it's like, just tell me what the problems are, so at least I know them, and then we'll move on to the cool stuff, and that's what we like to talk about. So, anyways,
and like I said, we're conservative, I think, in the development process. Like the browser cache is behind the feature flag, so we have a feature flag system that you can enable or disable features, and it's turned off because we know it's not like ready for prime usage. So when we introduce new things that we're not really like 100% or 99% sure, we put them behind the feature flag and turn them off by default.
okay,
That's good.
good. Okay, let me transition over here, this username, but DungDM93, I know is a user that comes from the Trino community, or at least he's part of the Trino community, may have been part of the Superset community as well for some time, but he ran over and basically did this awesome pull request, and basically he realized that the JDBC driver, which is what ultimately, or not JDBC, I can't remember. Do we say the JDBC driver ultimately gets called through the Python client? Was that right?
No,
Yeah.
no. The Python client goes directly to the
REST?
to the REST API. Yeah.
Okay.
But the headers changed, right?
Ye-
Like the HTTP header.
Yeah, where was
identifier
it?
had to be changed. So
Migrating guide, and I think if you're upgrading clients, so that we know for sure JDBC needs this JDBC Trino. That's going to be like a prefix that if you don't have that up to date with your JDBC, it's going to blow up. But yeah, I think it's this one right here, this protocol, and instead of saying Presto, you would say Trino. No,
yeah, and it's the HTTP header as well.
HTTP header.
Bit further up. I
Further
think.
up. This is-
Client compatibility there.
Oh, yeah, X Presto versus X Trino. Yep.
Yeah.
So that would ultimately break, and basically, I mean, so it's a ridiculously small change that's going on here, but it was, it will ultimately break and basically make it to where we would not be able to include this into Superset. So very simple change, but yet huge impact in terms of what we can do, and this is getting into some of the basically the database engine that Beto was just talking about. I wanted to take a quick look. This was shown to me by Srini, actually. So this is, in fact, I mean, I'm not going to be able to talk too much to this. This is basically the base database engine. Beto or Srini, do you want to hop in here and kind of explain what this file does? So
You want to make it a bit bigger as well, Brian?
Yeah, let me see if I can.
Yeah, I think Beta's probably more familiar with this than I am. So I'll let
Okay.
him.
Yeah, Beto, what's going on here in this base one?
Yeah, there's a lot going on. I mentioned a little bit. We have, like, if you look at the built-in time grains, if you scroll down a little bit, this was the first thing that we implemented in DB engine specs, and it's basically like how each database can take a column, a metric, and group it by this like specific time grain.
Got it.
And then there's a lot of functions basically like for autocomplete. So like, how do you get, given a database, how do you get the list of tables that is in that database for autocomplete? Given a table, how do you get the list of columns? How do you get the list of functions? that database support also for autocomplete. This part here is like basically mapping the exceptions we get back from the database into meaningful error codes.
Okay.
So like if you try to query a column that doesn't exist, each database will basically return their own error message, right?
Yeah.
So in each specific DB engine API, DB spec, we implement the logic that parses the error message and says, oh, this is a missing column error. This is a missing table error. This is a syntax error.
That sounds very familiar to things that we have going on in Trino. It's like the same problem. When you have plugins, it's like, it's great, but then it's, you have to map everything back to one common representation.
Yeah. So
cool.
And then, of course, like also different DB API libraries, they have different types. They call things differently.
Got it.
So there's stuff to do that.
So in this, go ahead. If you finish on your thought.
No, I was just going to say, so arguably with Trino doing things like supporting like higher precision time, for example, like we're going down to nanosecond now, and that in fact affected how timestamps are parameterized and that kind of stuff. We could work with you to ensure that that sort of translates all the way up to Superset that way, via this abstraction, right?
Yeah.
I think that's
awesome.
actually like the core thing that was done here. I don't know if it's going down to the picosecond stuff that we have or anything like that, but I think this is like potentially handling it saying truncate anyways. I'm imagining it's like
I mean, in the Superset UI, there's no way, as far as I know, to trigger past like more granular than a second, right?
Yeah.
Beto.
Yeah.
So this is really about explore, right? Because as we talked about SQL Lab, the query is mostly going untouched. So in the query generation, we currently just in the UI don't have a way to enable users to go more than a second. So that's probably the real limitation, I would say.
Gotcha. Unless you're doing.
We have to send a feature request for that so that you support higher precision, so you can do scientific plotting of whatever, I don't know. Well, high frequency trading.
Yeah,
right.
But this is for aggregating over time, right? You can always not aggregate over time, and then you get like
everything,
the values as precise as you have.
Yeah,
so that's the none.
That's work. Okay, cool.
Yeah. So if you look at the first value there in that dictionary, it's like none. It's like no time aggregation, and it basically you use the column itself.
Got it.
But if you want to have like the data average every second, you would use the PT1S, which is ISO standard for a 1 second interval.
Okay. Oh, that makes sense. Yeah.
And then there's some functions like, well, if you have like a native date timestamp, a time, how do you convert it to a Python object, which is the next method.
Oh, okay. So this is date versus just like a long value or something. So
this is like if your database has a timestamp, how do you build it from? It's like if you want to, like if you have a query, like if you're writing a query, but we're like internally in Superset, we treat time as datetime objects. Mm-hmm. So we need to map that to something that Trino will understand, right? Because it's a Python object. So this handles the conversion to something that
gotcha.
That Trino understands. Yeah.
Okay.
Time is hard also.
Oh man, don't even like time zones.
Yeah, time zones.
Like if you're going between like let's say the India's standard time versus and which is a half as some hours and a half off from like you know. It's
some
like
time zones are 15 minutes offset.
Yeah, exactly.
Also,
it's
like,
oh, and there's also you can't like there's some that are so close and like depending on like they'll use different time zones in the same geographical location as well.
Oh wow. Yeah, I know. I'm from Brazil. Brazil was weird because we used to have the daylight savings. We don't have it anymore. But it used to vary every year which day it started, which day it ended. Like Congress would approve, and then you can't automate things, right? Like if you're scheduling something 3 months in the future, you don't know if it's going to be daylight savings or not because Congress hasn't decided.
Right.
Yet.
You got to really focus on Congress's Twitter feed and make sure as soon as that comes out,
there just needs to be like an ORM on top of the Congress. So you get notified. You just ping it every minute.
Yeah.
Oh
Do
man.
you still have daylight savings?
Yeah, and then you have to have some sort of inference into like what the tweet means and saying if it is positive daylight savings or not daylight savings to fully automate that.
Yeah.
Oh man, and then they just forget to tweet, and then your system blows up. Okay, so cool. So that's basically jumping back into this PR. That's what this PR is doing. Like it's kind of getting some of the base functionality on how we're mapping, particularly our more complex time stamp stuff, so that you can kind of rely on those kind of group buys, those timing group buys that are kind of natural things that you'll like. I guess pretty common things. It sounds like that you're going to use in the user interface. So so without further ado, let's kind of hop into the demo now. I'd like to kind of cover real fast some of the steps that I did to set this up. So to set this up, like I'm using Docker, local Docker image, and I have like a typical Trino Docker image up that I use pretty much like every week. I've shown in previous episodes kind of how to set that one up. And we're also setting up actually a couple of these in another repository that we'll be trying to publicize here shortly. But I basically went to Superset's website and looked at the kind of intro. I don't know if I linked it here. I think it's these instructions. So if you go to Superset's website, they have documentation, and like very beginning of documentation is it's installing local using Docker Compose. So if you don't have Docker installed, depending on all the stuff, they great job here at documenting, doing a quick overview on like based on your OS, which one you should do. We have some similar stuff to this, but usually we tell Linux people to just go fend for themselves. But everything is super simple if you're on Mac and Windows. If you're on Linux, you have an interesting journey to take. So from there, like I'll step over to my instructions that are more Trino specific. You'll basically clone the Apache Superset. Let me actually go to this GitHub link here. So like if you look at Apache Superset, they have kind of, this is the entire Docker, or like they have their original like code, but then embedded is also like the Docker folders. They also have like their front end. Everything is kind of embedded all in the same project location here. And then you'll kind of go down here and see there's like 2 Docker Compose files. More recently, this non-dev was added to master. Yep. I know that's causing a little bit of chatter because I also kind of ran into this one as well. Srini, do you want to kind of explain what this Docker Compose versus Docker Compose non-dev YAML is for?
Yeah, I think I actually have not had a chance yet to use non-dev, but based on the context I have in the PR, I think it's not building the assets. So with Docker Compose, the original one, it will like fire up all the containers, including the init one, and then it'll like that will finish. But then there's like a superset_node, I think it's called, and that one will take like 10 to 20 minutes to actually basically run npm build.
Yeah.
And so so the non-dev one doesn't do that. I think it is just using
pre-built.
Using just the pre-built ones.
Yeah.
It's just using the pre-built ones so that people it can just skip that step. So that's one of the single most common things people ask about is, I have everything running. I did Docker Compose up. I go to localhost 8088 and it's like empty. So.
Yeah, so if you want to use like if you are developing, I guess, especially like on the front end, you would want to use the regular Docker Compose. But if you're not developing on, I think like the front end or doing anything, you're just basically playing around like we are, you would want to use non-dev, and that's just going to give you a pre-built like you would have if you did do the regular dev one, you'd have to go into the Superset front end folder and then run like your npm build and build it yourself, and that's going to take a couple minutes. And then once that's done building, then you could run the dev one. But if you're not interested in dev, which like if you're coming from a Trino perspective and you're just wanting to play around, you can easily just use this Docker Compose non-dev YAML one. So wanted to explain that in the instructions explicitly. So we first do this pull down this whole repository, and then the next step is underneath this Docker folder here. Did I hop out of that? No, cool. I saw this up. There's this Docker folder here once you first pull that in. So you want to change directories to the root of this folder, and then you can hop into like Docker in here. And you're going to want to basically create a folder underneath this directory in your local that is called requirements-local. And so you can just do this all in one command. And the basic line that you're going to include there is going to be SQL Alchemy -Trino. And if you look at our setup here, that's actually pointing us. I think it's this thing right here, right? Is this basically? It's basically a tag, I think, that is pulling you to how to. It maps this Trino value to the specific SQL Alchemy library that we're going to be invoking. If I'm not totally etching that, is that correct?
That's correct. Yep.
Okay, so basically, once you add that to requirements local, when you build Docker, it's going to point to it's basically going to load that library, and then once you've done that, then you'll go into Docker compose -f, and the -f is just to specify the non-dev YAML file, and then you'll just set up, and that is where we are here. So we have Superset up. There's a couple init nodes that I already cleared out of here. This worker beat seems to be constantly restarting. I have a very small amount dedicated to it, but it doesn't seem to affect anything. So I don't know if that's something that
could be a RAM thing. I think we recommend 8 gigs of RAM. But,
okay. Maybe
it could be that.
I honestly don't know how much I have in here, but yeah, and to be honest, occasionally, and when we run some of these queries, I have just a single. I have literally just a single coordinator / worker on this remote Trino. So a couple times, Trino might also crash on us on this demo. So just fair warning. So
that's a typical trap, by the way. When you use Docker Desktop, the default memory allocation is super low.
Yeah,
way too low.
I think I updated
it. Gigs of RAM on this laptop, and it's like 4, I think, is the default, or 6, which is like crazy.
Yeah, I think I have a little higher on mine. I don't remember exactly, but I don't think it's. I think it's 8 or so, but I can't go too much higher with. I have OBS also running on this guy, so it's pretty heavy. First thing, so this is Superset. I don't know if it's the first thing you see when you probably hop in. I think, what was the first thing you see? I think you see like a welcome screen.
There's usually a login screen the very first time.
Yeah.
You just type in admin, assuming you're using Docker Compose, and then you'll see this. Yeah.
Cool. Yeah, so it's like pretty flashy stuff. I have the dashboard. We'll hop into that later. First thing you're going to want to do once you have this set up is you're going to want to go to databases. So there's a little tab on the top that says data, and then it's going to have a drop down that says databases. And then there's a little plus and a database here, and you're going to basically just set the connection. You can name it whatever you want. I named mine Trino. I'm not going to actually do this because I have it already set up. And then you're going to use the SQL Alchemy URI that you need to set up. You can find this under the Superset documentation. There's a spot, let's see, so connecting to databases, and then we're down here now we very recently got added into the docs. So this is like, this is showing you the actual PyPy project, a SQL Alchemy project link here, and then you basically just have the connection string that you'll enter in here. And so some of these are optional, particularly like if you're logging into Trino where there's like no authentication, you can just like the password, obviously you won't have to use that there. And then based on how Trino, like one of the security vulnerabilities we just stopped recently, you can use, if your authentication isn't set up, you can use any username, but you have to have a username there. And then basically for host name, since we're using this kind of like mid Docker, kind of like between Docker apps, between Compose, you have to use this little hack that Docker has. So let me go back to this thing right here. I have the actual string. I should have probably made this code so it's easier to see, but it's Trino : / Trino as the user. That's going to be more or less any name you could put there. You could put foo, as long as it's not an empty string. And then you want to put host.docker.internal if you're using the same setup that I'm doing here. And then you can put :8080. Optionally, if you want to specify a catalog, you can do / catalog name, and then you would click add. This will all be in the show notes, by the way. It's already in there. I just basically need to fix up the way it looks. So in the end, it looks like this. You put a database name, specify host Docker internal and 8080, And one last little bit while you're configuring this that you should probably do is I ran into this issue and Srini
sure.
and Srini and Beto came to my rescue. Is I wasn't able to run show catalogs when I first got into SQL, and I was like, oh, this must be one of these kind of like weird little limitations on the query setup. And actually, well, the problem was is these four bottom ones check marks were not connected or checked in under the SQL Collab settings. So I wasn't able to run data modification queries, and I couldn't run create table as, I couldn't run create view as, and I couldn't do this like kind of multi-schema metadata fetch thing. So I basically just enabled all of these things and clicked save as well. And then that allowed me to do things like if I go, let's now, so once you set that up, you can actually hop into SQL editor. And so there's a tab on the top that says SQL Lab, and you jump into SQL editor. And then let's open up like a brand new editor. Before I was getting some weird thing whenever I was trying to just do show catalogs. So we verify our database is pointing to Trino. You can now like look to see these different schemas that we have. We're particularly going to be using Galaxy schema, but when we're running queries here in the lab, we don't actually have to specify these. You could specify these kind of like in any session where you don't want to have to sit there and say like, catalog.schema.table. But for our cases, I always like to have that in my queries. But yeah, now we can run show catalogs. Before, let me just go real fast just to show.
Just for context, also for the Apache Superset users, a catalog is basically the connection definition to a data source in Trino. So you can connect as many data sources as catalog, and so you can like have one that's the PostgreSQL database number one, another one next one number two, and then another one is like your Hive object storage, and another one is, and they're all separate catalogs. And then in the catalogs you have the schemas that could be like a database, so to speak, and then inside there's the tables.
Yeah, so if let's look at an example query. So in here we're talking to like a Hive catalog, and then in that Hive catalog we have so this is just like something that's specifying a particular connector that we're using, and it's going to have like particular properties that knows how to connect out to. In this case we're talking to an S3 object store. So it has all of our data stored in there, and it also uses Glue as the meta store. So all that stuff's configured on the catalog level, and then I can then create schemas underneath this. So I called this one Galaxy based on one of our Starburst more recent. This was a demo for one of our recent products that we released called Galaxy, and then specifically to the table. And so when we pull this out, we're actually talking to some Hive connector that is pointing to some schema that's created underneath it called Galaxy. You could think about this in like MySQL at this level is kind of like your database. And then after that, you're going to have underneath databases, you'll have like a table. So every single one has a little bit different. That's one of the things that maybe another kind of path that we can start working on coordinating is like, how could the Superset UI maybe encompass some of these different categorical hierarchies of like, different sets? Because there's even one you can go above on catalogs. If you did over multiple clusters. So like some databases also treat like different clusters as a higher level of containment categorization. And so you can like point to your AWS cluster dot catalog and there dot something else. And then you could have another cluster called on-prem cluster and then point to those. So it may be interesting to see how at some point if I'm sure it would not be an easy undertaking, and this would be something that would have to get presented to.
But we should do it. Yeah, we definitely should do it.
Yeah. So it'd be interesting to we can have that dialogue, moving forward from this. I think this is just a good initial doc. We're kind of running low on time, so why don't I rush along here? So we set up these two kind of. I think the flow that I found was really useful coming from Trino and coming into a Superset we started out, I played around running this data and basically built up my query, verified that the data I got back is what I was expecting and what I wanted. So here we have a flight table and a COVID cases table. Flight data is coming from BTS. It's basically just saying like flights from one location to another per row. And then you have COVID cases, which is basically the CDC. Every time they get a case reported, they record it to this database. And so we've scraped that, put this into S3, and now we're querying it through Trino, and then now pulling this out here. So this is grouping by the date. And then you get per date, you get a flight count and a COVID count, or basically number of COVID cases being counted in particular. Then I had another query that I did. We were looking at origin state and destination state. I also had to get an extra kind of copy of these columns so it could follow an ISO format for another one of the visualizations we'll look at. And then I just did the flight count from origin to destination state. So those are my two SQL queries. If I want to actually kind of like go and explore those and start seeing kind of like, okay, what I want to make some sort of like data set out of this. So this next kind of abstraction that Superset has goes into a data set. You can then like create this saved query and it becomes kind of like almost a view. I picture data set as like, can be either a physical representation of an actual table you have, or it can be like this saved query that is essentially like a non-materialized view, I would imagine. Let's go. So if we look at these things, we have these two, and I basically named them the exact same thing, and I changed query to be data set. Is that correct, Beto? You were kind of I think agreeing that this is.
Yeah.
Virtual ones are like unmaterialized views, more or less.
Yeah, they're like a view, but it lives on the superset layer.
Yeah.
So they could be a view on top of a view in database layer.
Yeah,
but
exactly.
They're like the superset view.
Views all the way down.
Yes.
I've definitely done that once, virtual on top of a view. But
Oh man, yeah. Like it's like how many views down before we get to the real thing. So if we go into one of these, let's say we want to actually like start visualizing this origin state data thing. If I wanted to create like a visualization on here, we'll create a simple, like we'll use this chart type as whatever this default is here. And let's run the query on just basically showing a table of the data. If it does.
Your last week, it's probably going to be the problem.
Yeah, that's right. So by default, it has the time range of last week, and this data is from last year. So we could do last year, or we can just basically take the filter off. Where is it? No filter. That's how I roll on Twitter. There's no filter.
And Instagram.
And I don't have an Instagram yet, but I should invest. Start making my foray out. So it's right now it's doing a query. It'd be hilarious if this was crashed Trino now. So yeah, again, when you're running this all on your own computer, it's a little slow, but it's fun to just play around. If you have a little AWS space, I highly recommend. Let me see. We're getting a count here. Is that is there something else I did wrong?
If you choose non-aggregate, then
they're all
so
records.
raw records.
Oh, there you
and
go.
then pick the columns. So you'll need to still pick columns afterwards. It's going to not like that you haven't picked any column names.
So
Okay.
I should have.
We'll do those
blocked
too.
The run button.
Run. I said it was a simple chart, but then I was wrong. Let's see. And here's where we would break Trino. No, Trino's still up.
It's chugging along. It has to do a lot of data retrieval, right?
No,
Everybody's nervous. Like, what's gonna break first? Trino or Superset?
The front end. Chrome just crashes.
Oh yeah, actually this is Trino down. Yeah, there we go. So let's restart Trino. It'll take it just a second, and then once it starts fresh, I should have just like let this thing. I should have run this query while we were talking, so that I could intentionally crash Trino, and now we should be good for a little while.
We could also limit the.
Oh yeah,
the time range.
That's
probably a good way to.
Or do a row limit even. Would that help?
If will it though? If Trino still has to to get everything. I'm
Yeah,
not
do you
sure.
have an index on the time column?
Yeah, exactly.
Let's see. Let's do. We can do like previous. Want to do? Let me see. We'll do custom, and we'll go back.
Yeah.
Specific time. We'll fill this up. March 2020. We'll go like September 1st to. And we'll move this.
There's essentially a lot of like really useful controls to build your query just in the UI, right? Like you don't need to type any SQL queries.
Oh,
you just
shoot.
build it all up.
I just clicked out of it out on accident.
I've done this many times. It took some getting used to. Yeah, this time picker is new. It's just in the last few months. It was part of 1.0. So there used to only be a few options. I think just there was a calendar, and then like last month, and now it's like a full blown, almost like a language, metadata language going on here. So
we went to November 1st. I'm actually can't. Oh man, you're kidding me. I think I should have gone to is December 1st, not November 1st. I know I have data in November, so let's do there on query. We'll get this simple table chart. There we go. We got stuff. Okay, so we'll call this table chart. And we can save that chart now. Once you have a chart, then you can you can basically reference that later. What we'll do is now hop into, you could create a dashboard. I've already created one before this. And so I start it, I just so that way it's at the top of my list. So that's kind of a nice useful feature if you have like ones you care about. You can do cool things like markdown. Look at these, all these things are querying Trino simultaneously, and hopefully let's see if Trino breaks again.
It's kind of like a notebooky thing, right? Like you can not just have the charts, but explanatory text and stuff. So I also noticed later that Brian showed me, you can expose them. So you can literally have a nice sort of like information website or info. You could kind of even like make an info chart, like, you know, how like.
And it can be interactive also. You can add like filters that if you select a value, it applies to all the charts. We can even have maps that would like, I built some dashboards where you had the map with zip codes, and when you click on the zip code, the time series, they filter to reflect only the zip codes you selected.
So here's the grand reveal of the COVID cases, right? So you kind of what we would expect. So on the left side, you're seeing the number of flights in a day given each place. And then on the right-hand side, you're seeing the scale for the number of COVID cases in a day. And so we see like basically, I think that's the case, right? Or is it what is it? Or,
and I have to say, for
like
any data nerd, that's just beautiful.
Yeah.
Like, I'm sorry.
So as we see, we start seeing a couple cases. March is when I think we in the U.S. is when we started enforcing kind of the lockdowns, right? So we start seeing these take off anyways, though, because there's still like, you know, a lot of people non-compliant. People are still moving around, but you see this sharp drop in the flights, and so this goes on for a while, and then eventually people just got tired. You could see where that kind of happens, and then the flights kind of go back up, and this is, I think, kind of our normal spot in you know, like kind of how we normally operate. We did go down a little bit just before the holidays, and then you start seeing it kind of pick back up during the holidays, especially the COVID cases here again, and tragically that happened around this time. So what I did was I wanted to kind of look at this pre-COVID phase of kind of January to March. And I wanted to look at this. So this is kind of pre-COVID, and we can then look at like, I think I did July to September. This is kind of, I would say, our average kind of default how we are using flights and how we see the COVID cases being discussed. And one cool thing too is you see these kind of jumps and hops, these very periodical jumps and hops in the data. I think this is like during a weekdays, and then like maybe hospitals aren't reporting as much during the weekend. So you see these dips, and then they kind of hop back up, you know, kind of make back up a little bit for some of the cases that were being missed or that weren't being reported over the weekend. So, and I have interesting things that you'll see in this data, and it's really nice once you visualize it. It's stuff that we don't typically get to see on the Trino side. We're just seeing a whole bunch of numbers come back. This is probably not super useful because it's very convoluted, but this is the to and from kind of thing. So you can kind of hover over Illinois pre-COVID. We were at 2.54, and then post-COVID. Or during COVID, I should say, it actually went up during that time in terms of like the number of flights going out from Illinois. And so I'm not sure if that could have been, it doesn't actually make too much sense to me, to be honest, that number goes up. So I could have had something really kind of wrong with my query going into this, but anyways, the idea of the visualization's there. May have to go check into that data, but then we can also do the same thing, pre and post and during COVID. You can visualize these, and surprisingly, I should have probably made sure there was like a scale on this to show you what is heavy and what's not. But if you hover over, I think you can get the basic gist of like South Dakota is very pink, so that is very pink in this scale means very low. And then like Texas, one of those kind of big central stations in Illinois are like where they have these big international airports and stuff, and a lot of even domestic type flights that are going there. So when you look at like the worst type of most flights happening across the board, you could see kind of Illinois and Texas and Georgia kind of taking the ringer there, and then you see kind of what is TT? That's probably a province or something that I'm not aware of. Mississippi is definitely low on the count. So that's the basic gist is like, if we wanted to then add our new little chart that we just had, we can click the edit button above here. Let me go to this charts, and we see this new table chart that just got created. And let's just say we want to put it here for sake of time. And once it's put up there, that pulls out the query out again, and we can scale this little table back up here. Maybe it doesn't even need that much space. Can scale, make it a little bit bigger there, and then boom, it's then a part of our dashboard, and we can maybe pull something up to fill it in here. Maybe this bar graph, and bring it back and forth. One question I had, and then obviously we want to save our changes, right? So we can do like share if you're somebody who's logged into Superset. And this is a question I actually think Manfred asked me yesterday, and it's now on my head. If you expose this in a certain way, can you make this kind of like a public thing, like website that people can go to without having to log into Superset? Is that an option?
Yeah. I think we don't officially recommend it yet. We did the security audit, and I don't know, Trino, do you know more about the status of it? Like, it's definitely in our roadmap to have the public dashboards. I don't know if we already encourage it.
So it's interesting because there's I just shared a link if you want to do that. But so there are actually some kind of public data for good projects that use Superset, a slightly older version. So you definitely can do it. Whether or not it's like, yeah, as Veda mentioned, like we haven't been, like the community in general hasn't been aggressively testing it on the security side. Usually people end up adding their own layer in front of Superset and then exposing that publicly. And yeah, I just, the link that I shared, the air quality data comments, they actually even let you run, I don't know if it's quite queries, but they do let you like run dashboard filters. So that means it's hitting some database, which is pretty interesting. So yeah, go ahead.
And to be clear, you can do this. You can make it public. There are roles in Superset that are for consumption, and they have only read-only access. So you can do this. It supports it. It just like there could be security holes that we don't know about. That we're still like making sure that we're hardening it so that you're not exposing your database or like your service, right? Cool. But definitely like there is built-in support for a role of users that are like, and if you're logged out, you can just consume dashboards.
Gotcha.
Yeah, there's a really detailed security model. We can have per role security access. We have a new dashboard access model where even if you don't have access to the underlying data, you might still be granted access to the dashboard that builds upon that data.
Okay.
So there is definitely a public consumption role.
Cool. Okay. Well,
that's pretty amazing.
I think, I mean, I was very outside of a little bit of difficulties, I think with some little gotchas, There's the DDL thing when I was trying to do the show catalog. There was the, kind of when you're compiling on Docker Compose stuff. But you guys are still like already even taking steps with that non-dev YAML file and things like that. But I really think for the most part it was super straightforward. If I had any questions, like I remember posting a question on one thing with the US map. I posted a question on how to, because like I was showing this France map and something like that, and which I think is the default. And then I was like, why is this showing France? And then I just I Googled it real fast, pulled down this video that you guys had created already, and then I found the answer. And before I even needed to wait for somebody to answer, I got that in there. But everybody's super, super helpful in your Slack community. Is there any other kind of way, if I'm kind of jumping into Superset, how do I get kind of involved from a user perspective as well as from a developer perspective? I'll give the user one to Srini, and then maybe Beto, you want to talk about the developer side?
Yeah, so I'll go first real quick. So on the user side, definitely, there's a few different ways. So I will mention that for people who are not technical at all, that don't, not familiar with the command line, we Preset, where Beto and I work, we do have a cloud hosted version. And so that's definitely one way people can try out the tool without having to jump through the hurdles. From the contributor side, though, we've actually just revamped a lot of our Slack channels in the Superset community. And so there's actually some friendlier places. We got beginner questions for people who can come in and bring the, any question that they have and not kind of feel ashamed about being too junior to ask the question. We have a hashtag contributing channel, and a hashtag using --Superset channel. So those are all ways where someone can come in and, assuming they've gotten Superset working or they have access to Preset Cloud, they can get some help building charts, or even figuring out how to tick the right boxes in the database settings as you encountered, Brian. So there's and I spend a lot of time in the Slack, so feel free. You can ping me directly, post in the channels. I'm there multiple times a day, and I can, if I can't answer it, I'll ping Beto or I'll bring in another person from the community that can answer the question.
Awesome. And Beto, so if you're wanting to get involved, if I'm a developer that's super interested in this visualization stuff or caching or any of these other cool elements that we were talking about today, how would I get involved?
Yeah, we have. So I think there's basically two ways. We have issues on GitHub that are tagged as appropriate for beginners, and those are usually chosen something that you can get started quickly, and the person that's going to review your work is gonna be aware that you're a beginner and help you set up and spend more time in the code review than you would normally spend, right? You're because it's somebody who wants to be part of the community. I think it's investing in the community, people joining it really pays off on the long run. That's something we really want to do is hey, we're going to spend time getting people set up and becoming developers, but it definitely pays off. We also do developer meetings every 2 weeks. These are open to anybody. And we're doing 3 different times. So every 2 weeks, it's a different time to be more friendly with people in Europe, people in Asia, people in the US. So we do those developer meetings. Everybody is welcome to join. Even if you never use Superset, if you're interested in developing it, you can hop on, introduce yourself, and just start to catch up with who the main committers are and what we're doing, what's the roadmap. The roadmap is public also, but I feel if you want to be a developer, being those meetings really help to get a sense of what's going on.
Cool. Very cool. I really value that. And all these, you guys do a great job of it. We try to do the same in Trino, making sure that we're investing in people long-term and making it a really safe space to be kind of, if you're a data engineer and really interested in this stuff, making that same kind of space. Real fast, Manfred, do you want to tackle the question of the week, and then we'll wrap it up. This super long episode we've had this time.
Yeah, sure. Hang on. So, what is the question of the week? The question of the week is related to what we talked about already, and that is the REST API. We continuously get questions about I just want to talk to the REST API, and while that's possible, the default answer is basically don't do that because because it's complicated, right? Like as I mentioned earlier, the REST API is not a default REST API. Like it's not just, you know, you do a HTTP post and then a get or whatever, and you get the result. That's not how it works, because obviously when you like query a database, you get like the first 100 records, and then you have to request more. And the Trino cluster will not get all the data, like 1,000,000 records or whatever, if you're just looking at the first 100 or so, right? So it doesn't go and kick off that process. So if you want to work with the REST API in order to retrieve data, the real answer is don't do that, because that's complex and hard to implement, and the clients exist to already deal with all that. So we have the Trino client for Python and Go, and the JDBC driver and the CLI. All of those deal with all of that complexity. So if you want to just run queries, just use one of those clients. There's other clients for like R and JavaScript and stuff like that as well. And if they don't do what you want, maybe help us make them better to do what you want with it. That's always the thing, right? Like open source projects, that's the whole idea. We work together to make it do what we want it to do. So do that. And then if you are really ending up on a platform where there just is no client, I don't know, like some other programming language or a platform that doesn't really have it yet, like, I don't know, C# or whatever, then potentially look at the docs and look at another client and sort of like implement along those lines. But don't just write it for yourself and then like keep it to yourself. Like help us make it open source so that others can help you, that you can collaborate with others, and we enlarge the ecosystem, right? The same would apply for like SQL Alchemy dialects and stuff like that. It makes no sense to just invest your effort, do your own little thing, invent the wheel, and then let it rot.
Totally.
Just open source it to the community. Now, there's one part to the REST API. Like if you really go down that route, we do have a wiki page that we'll link in the show notes where it is explained how it works, and then work on that. The last aspect is we do have some parts of the REST API that are useful. Like there's an endpoint, for example, for v1/status and v1/info, for example. What they do is they just show back that the Trino coordinator runs, or the like these like so many workers are up. Like there's a little bit of like super lightweight information, and those are pure REST API endpoints, and they can be useful to do like liveness or readiness probe sort of thing on a Kubernetes deployment, where you just need to know that it's actually running, right? Like you can hit those endpoints just fine. Obviously, you can also hit the Trino web UI. It shows you that same information, and in fact, it sits on top of a bunch of more of those kind of REST API things. So you can even get to like query plans as JSON result and that kind of stuff. So you can explore that. But generally, if you really just want to run queries, don't work with the REST API.
Okay, cool. Well, with that, thank you very much, Srini, and thank you very much, Beto, for enlightening us and having your community join us as well to kind of learn a little bit about Trino and let us learn a little bit about Superset. I think there's a lot of work we have in the future together, and I'm really looking forward to kind of establishing that relationship and solidifying it even more. And with that, one last little bit, music for the show is from Mega Man 6 gameplay album by Krzysztof Slowakowski, and that is our show. Thank you all for stopping by.